how the switch hub will work. So if earlier days, what happened? The communication between the systems. So olden days, if you see, we had like a directly they are connecting to the PC. So one will become a host, one will become guest.
One will become host and one will become guest.
Guest, right.
Host.
So it's like only two PCs that are connecting using the cable. So now only these two pieces was communicating. So that is what they have done. They have come up with NetBIOS network. Then they started with the topologies, star topology, mesh topology, ring topology, like that. So there's a lot
Yes,
of
sir.
things. Lot of things is there. Now we'll come back to hub and switch. Normally we'll use this, right? So you know about the hub. Here, instead of
Okay.
suppose if I go with the mesh connection, if I take a 5 PCs, for example, or 4 PCs, so all the pieces are connecting together, right?
Yes.
So what is happening here? So maybe A PC connecting with B PC, C PC, and D PC. If you go with A PCs, you need to have a 3 cable to connect C
Yes.
PC, D PC, and B PC. So like that, if you have 100 PCs, you need to have a 99 cables, right?
Yes.
99 cables, and moreover, if you connect like this, you need to have a more number of ports in the same pieces. Only for 100 PC I'm talking about. And the cables, the lot of cables are there. In case of any link failure, it is very difficult to find out and which link failure. So the cables are messy. So that is the reason they have come up with the topology. Now, for example, we had a lot of devices. There is a bridge, there is a repeater, lot of things. Now we'll talk about hub, using a hub or a switch. So say it's a centralized, like your multiple PCs you are connecting. Suppose if I go with 4 port in the hub,
Okay.
you are connecting 4 PCs. Now in a system, you have only one cable. Using a one cable, you have connected with hub. And if you want to communicate with APC to DPC or BPC or CPC, it is simple, right? The link will go through on hub, right?
Yes.
Now, if you see the difference between hub and switches, so hub is it's not a intelligent. Switch is a intelligent. Very simple way if you talk about. See, for example, PC A wanted to communicate with PC D. We talked about the packet, right? PC
Yes,
will
yes, sir.
create the packet, source IP, destination IP, right? Source MAC, destination MAC.
Yes.
Source IP is A PC IP address, destination IP is DPC IP address, source MAC address, destination MAC address. Okay, maybe source MAC address is A0, destination MAC address is D0. Source MAC address is A0, destination MAC address we doesn't know. Hub will do what? Hub will receive the request. Hub will do what? He will start sending. Array, I'm finding for D. Destination MAC address. Are you the destination MAC address? He will inquire. Now this guy will reply back. Okay, he will understand. This is D0. He'll assign the MAC address of D0. Send the request. Again, APC wanted to communicate with DPC. He is not intelligent. He don't have any table. Again, the same process will happen. Right? Same process will happen. That is what we have as switch. Switch will do what? We talked about switch, right, Abdul?
Yes, yes, yes.
How the
Yes.
switch will work. Switch have a MAC table entry. So you can have a 8 PCs, 16, 8 port, 16 port, 24 port, 48 port switches. Right? All the pieces are connected. It has a MAC table. So first time he will identify, he will send like this. He will send like a broadcast. He will broadcast to everyone. Then he will maintain in the table port number and the MAC address. So those, based on those information, you'll start communicating. This is based on the wire, right? All the pieces are connected through on the cable. You need to have a port like your NIC card, and those port you're connecting to your switch. So those, you need to bring the cable, you need to connect to the port, right, Abdul? This is in
Yes,
case
yes,
of
yes.
wire. Now we'll come back to the wireless. So what is the difference between wire and wireless?
Wireless, it is through wireless is it is the network through the signal without wire.
Exactly.
Uh,
This is signal, this is radio frequency,
mm,
through on radio frequency. Then here we have either hub or a switch to connect the PCs. We require a cable to connect all the PCs. We'll connect through an hub or a switch. But what about wireless? We need access point. It's a device, right? It's same like your hub and
yes,
switch, but
it is.
not required any cable. Cable is not required. Now, how you are going to connect? See, same like your switches, we have a particular PCs, right? Maybe here, if I go with the 16 port switch, how many PCs you can connect?
16 PC switch, we can connect at least 15,
Ah,
16.
16. Let's assume I don't have a multiple switches, only one switch. I can connect 16 PCs, no?
Yes,
There is a limitation right here. But whereas here
yes.
in the access point, you can connect multiple pieces. We don't have like the switch number of pieces. It's not like that. Suppose I have your access point. So I have a multiple pieces. So it doesn't say the network, maybe the same network or a different network. You are connecting to the access point. Now it is a 10.0.0.0 network. They'll communicate each other. He is sharing some information. So some of the file everyone can access. See, access point, it's not a router. It will not do any firewall function, Abdul. It is only
Yes,
a
yes.
switch, how the switch works. Same thing. It will work only the same networks. How the switch you know, right? Similarly, it will
Yeah.
work. We don't have any routing function. So these two pieces in different network, these pieces in different network will route through on the access point. No, it's not like that. If you
Okay,
want to do the routing, suppose I have a 11.0.0. network, your 10 network. You need to have a router. You need to connect through on the router to the access point.
okay.
Then only the routing will work. You need to specify the routing here. And access point, you can use in the case of access point, multiple way. Like one is wireless,
Access point.
wireless to wireless. See, I have a PC or one of the PC 10.1.1.1. Here, maybe I have 10.1.1.10.
Okay.
So this is also through on the antenna, through on the wireless. Here we have a, in the case of your in switch network. So every pieces we need to have a NIC card, right?
Yes,
NIC
yes,
card,
yes.
we are bringing the RJ45 connector will connect to the cable. But here we need to have a wireless card. Then it will send that signal. So it will send the
Okay.
signal to the access point. Here we don't have any cable. Anybody can connect, right, Abdul?
Yes, yes, yes,
That is the
yes.
reason we have SSID to protect our network. Now, whatever the SSID, maybe I have a SSID of 123 at the rate ABC, for example, the same SSID you need to specify to your system, right? If you go to
Yes,
the
yes.
wire Wi-Fi, you
You will
specify
get the
the
name of.
password. Yeah, once it is matching, it will do the authentication. Those who have the same SSID, they'll connect to this access point.
Okay.
So this guy can communicate with this guy now. So wireless to wireless connection, yes, possible. Now wireless. wireless. Maybe I wanted to connect to switch here. Here I have one more access point. So I have a different cabinet, or maybe I have a multiple pieces here, multiple pieces in other cabin. I need to connect both. So access point, I'll connect to the switch. From the switch, I'll connect to the another access point. So wireless to wire, it's also possible. It is possible. Or suppose I have one of the server here. I don't want to connect my server to the through on the wireless. So I want a cable. I'll buy a cable. I'll bring the cable. I'll connect to the access point. So from there I'll communicate through on a switch to other system. Yes, it is also possible. Wire to wire.
Okay.
So how you want your connection? You have a requirement. You can connect like that using the access point. So wireless to wireless, wireless to wire, or wire to wire. Okay, it is similar to your switch or a hub, but the functionality is different. Like your card is different, and you need to have access SSID for the authentication to trust. Trust.
Okay.
So this is about the access point. So required anything, Abdul? I thought I was
No.
talking about the routing. Do you want to
Yes, yes.
understand the protocol? I said dynamic
You,
protocol.
dynamic, you said RIP, RIP,
Yeah.
OSCPRF, and static dynamic.
Yes. So if you see routing protocol, one is
Sir, why they are using NAT routing, NAT protocol?
okay. So network address translation. Now we'll talk about inside the organization. All the PCs are connected. What kind of IP they are using? We have a two kinds of IP range, right? One is
Public and
public,
private.
private. Yes, absolutely. So what is it public IP? What is it private IP?
Public IP is it is getting from internet. Private IP
To connect
is
to the internet. This is inside the network, right? Inside the
yes,
network,
sir.
private IP. Okay, inside my organization, for example, I have a private IP address 172.16.0.0/24, for example. So here it is 1.1, 1.2, 1.3, 1.4. So 172.16, 1.1, 172.16, 1.2, like that, for example. Now, this network is connected to the outside network. This is an inside network. It is connected through an internet. It is outside.
Okay.
So through on the internet, maybe I have in the other branch, I have a one of the server. So maybe it's a web server. Maybe this is connected to 182 network, 168, 10 dot, maybe 0/24. Now this guy, 172.16, 10.10, one of the user wanted to send a request to web server. So that is 182,
Okay.
168, 10.10. So Abdul, tell me, using this private IP address, can you send a request through on the internet?
Sir, madam, this IP is different. We cannot.
No, here I have a router, no? That is the reason. Here I have a router. Here I have a 172 network. I can communicate with 192 also. I have a router. Router will take care. I may configure a protocol, RIP protocol or OSPF, or maybe a static. It is possible, right, Abdul? Now, my question is, using this private IP, can you send a request through on internet?
Private, we can send the request through internet.
Internet, if you want to send a communicate through on the internet, we required which IP?
Public.
Public IP. So using the private IP address, can you send a request through on public? No, right? Through on the
No.
internet. Not possible. Not possible. We need which IP address? Public IP. The request wanted to
Public
go
IP.
through on the internet. We need public IP. And moreover, we required a protection. So if I send this IP address, right, Abdul? This
Yes,
guy
yes.
is receiving, let's assume here, this guy is receiving 172 IP. Now, maybe there is an attacker in the other organization or maybe in the internet, there is an attacker. So seeing this, your private IP address, 172.16.10.10 is one of the PCs. So he may send a request to access your PC. He may attack your system because this is your system IP. So I don't want to share my system IP address, right?
Okay.
That is the reason to provide a protection. We have NAT. So NAT will do what? It will translate the IP. For example, from the public, I'll assign one of the IP address 5.5.5.5. This is my public IP address to my organization. I have bought a IP, internet IP. This is the IP. Now, what
Okay.
I'm saying is, I'll configure NAT, network address translation. So what NAT will do, whenever you send a request through on the router will remove this IP. Instead of that, it'll assign public IP. So that request, it will go through an internet, one thing. And also, this is not your system IP address. Right, Abdul?
Yes, yes.
It will translate. So now, whenever the PC is sending a request, PC will create a packet, ICMP packet. In that, you have source IP address, destination IP.
Yes, yes.
Right? Okay. Source IP, destination IP. And there is a source port, destination port. Okay, source IP is 172.16.10.10. Destination is 182.168.10.10. Just an example, I have not created any NAT in the outside network. And source port is the 80, this is something. So this packet is created by PC. He will send to router. Now when the NAT is enabled, right, Abdul? Router
Yes,
will
yes.
do what? Router will translate the IP. So source IP is
Source IP is
172.16.10.10. So it has to translate 5.5.5.5 to destination IP is 192.168.10.10. Now he will assign, router will assign this packet. Now from the router, whenever it's going to the outside network, it will remove this IP.
Okay.
So it will become only source IP will become 5.5.5.5 and destination will be 192. Okay, source port, destination port. Okay, now the source here, server will receive the request, right?
Yes.
Now this guy has to reply back. Now whenever he'll reply, which is the source IP and destination IP?
The source IP is what you said
So,
172.
source, now this guy is the source. 182.168.
58.
10.10 is the source. Destination is 5.5.5 because he doesn't know the 172. Now he will respond back to this packet with the 5. This packet is receiving by router. Router again, he will see that 5. 5 I need to translate like 172.16.10.10. He will translate this IP. They are protecting your network, right?
Okay.
And also you are hiding this IP, private IP. Instead of private IP, it will use public IP to send a request through on internet.
Okay.
Fine. Yeah. This is about the NAT. Anything?
No.
So any question, Abdul, or you have anything to understand in networking?
No, actually, I need this much only: switching, routing, and access point.
Access point. Okay. You know about the VPN also?
VPN, little bit.
Okay. You need to understand anything in VPN?
Madam, in the switch, we are using this protocol, no, VTP.
Yeah.
Why VTP is used?
So this is like your VLAN trunking protocol. I was talking about, right? Switch, you have a
Yes, sir.
switch, and here you have a switch. So in the switch, I have a VLAN 10, VLAN 20, VLAN 30. And here also I have a just an example VLAN 10, VLAN 20, VLAN 30. Both the switches are connected. So here by default, the port is access port. Only one VLAN it will allow. Now, if you want to allow multiple VLANs, you need to enable this port as a VLAN trunking protocol.